As you know, you signed up. It's motor controls and circuit protection, and in here to help me out today is going to be, actually, I'm here to help Tom out. Tom Volosky, he's my sidekick and partner in crime. We put these Automation Talk shows on, so usually we can conjure up some other guys from other teams, but Tom has a pretty good background and knowledge in this topic, so...
where I got my start.
Yep. So the agenda real quick, we're going to go... motors. We'll cover a little bit about motors just because obviously, what we're going to talk about today is controlling motors, right?
Yes, sir.
Contactors, overloads, and starters. Tom's going to talk about the basics, what you'd need, why you'd need them, and what to get you started, where you can find more information on them. Circuit protection, we've got several different styles there. Motor control relays, which are basically some accessories you might not need, but they make life easier in your applications.
More recent products we've added.
Mm-hmm. AC motor soft starts, those are new products as well.
Yep.
And then also we'll talk about motor drives or VFDs as known. But so we'll go ahead and I'll turn it over to Tom and let him get started on the first one.
Well, the first thing, Shane, is motors. I guess if you're going to talk automation and control, motors are probably the key behind automation. I mean, before we had automation or PLCs or relays and stuff, most machinery and conveyors and processes and everything, the Industrial Revolution actually took off because of motors and everything, and eventually it became apparent that the more you could control motors, the better you could produce product and control processes. So in our case, and I'll have Shane help me here a little bit on motors, we basically carry two different lines of AC motors.
Right.
And again, the whole webinar we're going to give today is in regards to control motors, and in this case they're going to be three-phase AC motors, so we're really not going to touch on DC motors, but stay tuned. Those might be coming down the pike sometime here in the near future. And also, even though we do have some single-phase type applications with motors and VFDs, we're not really going to hit too much on them. So our name brand motor is basically our Iron Horse brand.
Right.
We go all the way up to 300 horsepower in that units, and we have 1200, 1800, and 3600 RPM varieties of that motor. And we do, even though we're not going to talk too much about single phase, we do offer a single phase version. And in the line of marathon motors, those would be more in line with inverter duty type motors that we sell.
And motors, we did do a talk show on motors themselves, so if you have a chance and you didn't get to see it, we have it in recorded format, so just go back to Automation Talk, look at the recorded seminars, and watch the one on the AC motors that covered it. And also we had one on drives themselves, on AC drives.
AC drives,
and we had one of our specialists for drives, Bill Boatwright.
Mr. Boatwright was with us.
Tech support guy. He extremely knowledgeable about drives, but we have a recorded one on that as well, so you can go back and watch it. And then also, you'll notice on the slide is the website.
For the motors down there at the bottom. Continuing topics during this presentation, we're going to try to keep this organized. So we're going to talk safety, and then along with safety, we're going to talk about, because there is a difference between short circuit protection that's required in motor control type circuits versus overload protection. And we're going to talk about operating protection. That's when we'll get a little bit into the under an over voltage type and phase loss type relays. And then finally we'll talk a little bit about performance. So basically, again, we're going to talk about anything that has to do with controlling motors, but also protecting motors and the circuitries that go to the motors. So the first thing we're going to talk about is starters and overload relays. Basically here at Automation Direct, we carry three lines of motor starters, overload relays, accessories. Basically it's Fuji,
right?
The Eaton Cutler hammer, and then our own brand, the GH series.
Right.
These all serve different types of applications or ways you might use them and everything. So to start with, we'll jump right into the Fuji motor contactors and relays. And basically, Shane, in your hand, you have the Fuji, some of the smaller.
Yeah,
these go all the way up to
I'm lazy. I don't
something
want to hold
like
any
300 horsepower. So we don't have the big ones here today, but basically what Shane has in his hand, we're going to talk about that top device with the switch on it. That's in our second slide, but that's a manual motor starter.
Okay.
So we're going to start by talking contactors.
Which is
And we carry, in the Fuji line, we carry 2 different brands, or not brands, but styles. One's the dual. That'll get us from a half horse up to 100 horse, and then we also carry the Odyssey series, which gets us all the way up to the 300 horse.
Now let me stop you real quick, Tom, and ask you a question. So I'm not real proficient on motors and motor controls. It's not my strong background, but I'm going to play stupid if you will let me. Let's just say that I have a motor and I want to control a conveyor. Obviously, I just can't put a light switch on it and just power it straight up, especially if it's going to be 3-phase. So I need to have a contactor, right?
Yes.
Can I just
technically, let me interrupt you for a second. Back,
okay.
We started out with the Industrial Revolution and motors being, what brought industry up to speed and everything. And back in the very old days, even before my time, there were actually 3-phase motors where they actually had a big toggle switch with 3 poles on it that actually you would use to turn the motor off and on, just like you would use a light switch, that turn your light off and on.
Now, if you use a contactor, you can't use just the contactor. You have to use some other devices or accessories, right?
Exactly. To meet different codes in different parts of the country, or state and local codes. And for safety, we're going to stress safety and circuit protection, short circuit protection. I mean, if I took the motor and set it out there and just took the contactor, and let's say the full load amperage on the motor was 10 amps, I had a contactor rated at 12 amps, so I know I'm going to be able to carry the current that's going to the motor. If that's all I did and I had the proper wire size and everything, that would be fine. But if something stalled the motor, whatever the current, when you stall a motor, the voltage starts getting pulled down, but the current goes up to try to maintain the same amount of horsepower, and eventually, something's going to
something's got to give.
And so controlling it is not by itself is not a good idea.
Okay, but with the addition of using overload protection or something like that,
then
this is the simplest solution.
Exactly.
Okay.
Yes. So in line with the Dual and the Odyssey series, and as you can see up there on the slide, we offer, we're talking a contactor, and we'll clarify there real quick. We have contactors, we have overload relays. The 2 of them together is typically called a motor starter.
Okay.
And we'll get into that and show how to put one together here real quick.
Okay.
But basically, we want to remotely control a motor, so that's why we use a contactor. We can use a control voltage, and as you can see again on the slide, we offer the various coil voltages in 24 volts, AC, DC, all the way up to, in this case, we recently came up with some high voltage coils up to 500 to 550 volts AC.
So I can use a secondary device like a PLC to actually turn on the contactor.
Exactly.
I got you.
Yep.
Okay.
Yep. Jumping ahead here, we have our contactors, and as you can see on the slide there to the right, those are actually motor starters because they're a combination of a contactor along with an overload relay.
Okay.
The next slide, we're going to look at our overload relays, and again, with the Dual series and the Odyssey and the Fuji line, we have 2 different things. And Shane, in his hand,
yeah,
that's actually
the slide's better.
The TKE series that'll work with the Dual series, and we had one around here. I don't know what happened to it, but we also have for the Odyssey series a larger one.
No, this has some buttons and looks like some type of potentiometer or something like that. What is that for?
Okay, the overload relays are actually sized in ranges. So if your motor application or the motor you're using, you're going to look at the nameplate and find out the full load motor current. You're going to look at your application. You're going to look at things like how much you're loading the motor,
right,
and everything. And you're going to pick the overload based on not only the full load current of the motor, but you're also going to pick it based on the environment you're putting in, temperature, and everything else. But basically that overload has to be sized to the proper contact, so you can't take one of our big contactors and one of the smaller ones, physically they just don't fit.
Right. So they're made to go with a specific series, basically.
Exactly.
And these are adjustable because, so like you said,
You're going to get a range. So you might have an application where the motor's rated at 11.2 amps. So you might pick an overload that's in the 9 to 12 amp range, and the little yellow pot on there is going to allow you to adjust that current. And basically, there's different series or classes of overloads. That is a class 10. It has a certain amperage curve on it that gives you a certain amount of adjustment and everything that you actually marry up to the application or the motor you're using and everything. Also on the front of that is a reset button, and I'll have to double check on this, but I'm fairly sure.
So you can trip it and test it. There's a reset, so if it does trip, you can reset it. So almost like a circuit breaker in a way, right?
Yep. And that series, I think, is manually reset. We're also going to cover in our GH series, I think it is, where you can actually set it for an automatic reset, and we'll get into that a little bit further. So our next slide, we're actually going to show a typical wiring diagram, and before I forget, we threw these wiring diagrams together just to give some reference to how you would actually wire up a motor starter with your circuit protection or your fuse disconnect, as we show. In this case, we're looking at a 3-wire control. One of our engineers back here pointed out that this was kind of a quick and dirty example of a wiring diagram, but normally if you were going to make a schematic or a wiring diagram to show motor control or any kind of automation control, you'd also want to show wire numbers and your terminal blocks and everything. And some reason we didn't have them on our slides, but we did have them out here on the table, so I'm going to grab one. But also out of your control panel, and we probably would show it on our wiring diagram, you'd want some kind of terminal shown there through a power distribution block, as I'm holding my hand, to take the power out of your panel out to a motor if we're getting into larger wire sizes and everything. So I thought I'd point that out. The main thing on here we want to point out is we're showing a contactor wired to an overload relay, and we're showing the control circuitry for starting and stopping that motor through the contactor. We're also showing a fuse disconnect. And there's a note on there that says the contactor with the overload relay becomes what we refer to as a motor starter, as we've said a couple times so far. But the main element I wanted to point on there is we call that 3-wire control. And when we say 3-wire, if you notice, there's wire numbers 1, 2, 3. That's our 3 wires. They go, if you can picture this, they go from the control panel where you'd actually have the motor contactor overload and your fuse disconnect out to the 2 buttons wired on your door or a remote push button station someplace. And basically, we said we're going to stress safety. So here, if you follow me real quick, you push the start button, you pick up the contactor. There's an auxiliary contact under the coil of the contactor labeled M1. That's a seal or hold-in contact that allows you to release that push button if you've never followed this before. And once you push the start button, the contact seals in, it stays in. That's good. Your motor's running. Now, as long as we don't have an overload condition or a short circuit that takes out our fuse disconnect, then it's going to continue to run until we either lose power or walk up to it and hit the stop button, which basically drops out the contactor and unseals the circuit. The main reason I bring all this up is from the safety standpoint. If I have some kind of baler or something and it's running and I walk up to it and stop it and I lose power without this circuit, and I walk up and think, well, geez, what happened? I end up sticking my hand into an unsafe place, and all of a sudden the power comes back on, and without the circuit, the machinery is going to start up and somebody's going to get hurt. So
no, you're going to get hurt.
Yeah,
you just said you're sticking your hand in there, not me.
So with a 3-wire circuit, the main advantage here, if I lose power and power is restored, the motor's not going to start up again until somebody physically or manually goes over and pushes the button. So that's my whole spiel on 3-wire control.
Nice document you created there, Tom.
Okay. This next slide, basically, it's the exact same circuit. All we're showing is the fact that you can, instead of using a fuse disconnect for your primary short circuit protection, you can also use a circuit breaker that we're going to talk about here in a little while.
Okay.
Next slide. Not only can we do, take a motor and take a contactor and an overload relay and stick them together and
That's
control
sort of
that
what you
motor.
have here.
Yeah, exactly. We can also take two contactors, and by wiring them together, we can actually come up with a reversing starter. So in this case, it looks a little bit cumbersome there, but we actually show two contactors. There's actually, it's hard to see, but Shane's holding an example of one. In between, there's a black piece of plastic.
Right.
That's actually a mechanical interlock, and if you push in on one of the coils on the front and hold it in with your finger and try to push the other one, it's not going to let that other one energize.
Right. It locks it out.
It mechanically locks it out.
And vice versa. Oh, that's pretty cool.
Okay, so that's your mechanical interlock. We don't show it on the wiring diagram, but typically each contactor would have a normally closed auxiliary contact that's wired in series with the start circuit or the button of the other one to give you an electrical interlock.
Okay.
So that's a little bit of a spiel on reversing contactors. And out of our lines, both the Fuji motor starters and the GH series have the ability to be wired up as reversing contactors. Our next item in the Fuji line is our manual motor starters. We said we needed a contactor, and by all rights, we need some kind of overload protection for safety and everything. And basically, what Shane's holding there, that top part is, actually a motor starter. It's a manual motor starter, but it has the contacts built into it, but it also has the overload protection.
Okay.
These are sold in different current ranges. I think we carry two different sizes, a 45 millimeter and a 55 millimeter. They're available to control up to 60 horsepower at 600 volts AC. Rotary handles, there's on-off trip indicators on the front of it.
So I can actually attach one of these through my enclosure, right?
Yep.
So I can turn it on and off.
Yeah, and what I was going to say, that's the optional extension operating handle there. What I was going to say, what Shane has in his hand is not only the manual motor starter, but basically what we've done, we've added a contactor to it, and there's also a wiring device that you can buy that allows you to, it's pre-wired, so it allows you to go from the manual motor starter down to the contactor, and then on the back is a base unit that everything attaches to.
So everything's nice and snug, and it all looks like one piece once everything's made together.
Yep. So
cool.
In effect, what we have there is a combination motor starter. I mean, if you go online and try to look for a combination motor starter, you're going to find some kind of enclosure with an operator handle, and inside you're going to have your short circuit protection, you're going to have your contactor, and you're also going to have your overload protection.
But taken apart, these are individual components, but all together it's a combination.
Combination motor starter.
Okay.
And also, we should point out the last item on the slide and everything. I probably can't see it in the video there, but on the front little handle that turns off and on, there's a little slide tab that you can pull out, and in the handle there's a hole where you can actually put a lock or a device to keep somebody from turning this on during.
Lockout, tag out.
Yep, exactly. The next slide, we're showing a little quick wiring diagram. So we're showing the manual motor starter controlling the motor, and technically that's all we need. We have our protection and everything else, and in some applications that's all we would need.
And that's the simplest of starting a motor, electrical three-phase motor.
Yep,
but
simplest and probably least expensive.
But that's the only controls you have is it's on or it's off. It's going to be full RPMs, full current, full voltage.
And we should say everything we're talking about so far, because we'll get into this a little more too, is across the line starting. So we're taking the motor and through a contactor or a manual switch of some sort, we're applying full voltage across the line to bring that motor up to speed. In the next slide, with the Fuji manual motor starter, we also, on this one I have here, I can take it off. Maybe that'll help. It'll show you the actual size of the 45 millimeter. And what we offer is either a shunt trip auxiliary or option, or we also sell a undervoltage trip, and basically, this just goes on here. There's a little tab you push down, release it, and what the shunt trip does for you, and it's available on 24 volts DC, 24 AC, and 120 AC. I can remotely trip this. So if I have this, remotely, like some kind of pump house or something, and I have this on running the motor, and I have some kind of remote control station, I can actually have a push button or something in there and actually hit that button and apply 120 or whatever voltage to the shunt trip and actually trip this out,
Right.
and then stop the motor.
So you might have some HMI or something like that back at the office, and you're watching,
Something.
something's heating up, something needs to be turned off versus sending someone out. You can just shut it off.
Shut it off remotely. Cool. And then there's also an undervoltage, and what that does for you, once the incoming power goes under voltage, you don't want that condition because the motor's going to, keep trying to produce whatever power it needs. And if your voltage goes down, the current goes up, and that produces heat and other problems.
Bad things will happen.
Yep. And the last one here, we actually are showing where we take the manual motor starter along with a contactor on the base like Shane showed you later, and we have the same 3-wire control scheme that we showed with the other Fuji contactors.
Okay, before we get too far, I'm
Yep.
sort of monitoring some of the Q&A. We've had some pretty good
Okay.
questions come in so far, but one of them, somebody's asking, can you explain again what's the difference between a starter and a combination starter?
Okay, starter basically is going to be a combination, and maybe I shouldn't use that word, but a starter is a contactor with overload protection.
Okay.
Whereas a combination motor start, and you would call that a starter. So if you look at what Shane has over here,
Basically just these two pieces.
he has the contactor on top with an overload on the bottom. So a contactor, overload relay becomes a starter. If I add, my short circuit protection in the form of a, fusing or a circuit breaker and the fusing with a switch, now I can kill power to the whole thing. That becomes a combination motor starter.
Okay.
Hopefully that answers the question.
Okay, thank you. Yeah, because when I read it, I'm like, All right.
Finally, we get into our other line, and Shane has this one. We also carry the Eaton Cutler Hammer line of motor starters. Basically an IEC.
Let me stop you there.
Sure. Yep.
Because that was another one. It's, all our IEC. Is there NEMA? Do we sell NEMA? If there is there differences? And do we,
Currently, this goes back some years and everything, but we do not currently sell NEMA type motor starters or contactors. IEC being the European brand has become more popular over the years and everything else. I guess if I go back in my career and everything, and this is kind of hard to explain, but NEMA, the NEMA ratings on motor starters and everything are fairly robust.
right?
Very heavy duty. The contacts, the hardware, everything else is very robust. But along with that, the robust part of it also means larger size, more expense, more materials, and so on. And don't get me wrong, there are applications where you probably still want to use NEMA. IEC allows you to get a little closer to good longevity if the motor starter is matched to the application of the motor.
Right.
But with less materials, less expense, and you still get
Smaller
the performance
footprints.
and a smaller footprint.
And you can't say it's just one manufacturer over another because Fuji obviously is an international manufacturer. Overseas, Cutler Hammer is an American company, but they're still making the IEC as well.
Exactly. Yep.
Okay. All right.
Also in the Eaton Cutler Hammer, we only offer them the 120, 240 volt. They do come with one normally open auxiliary contact. The overload relays is a little bit different situation than what we had in the Fuji. What Shane has in his hand is actually the heater.
Looks like a resistor.
It looks like a big resistor, but those are basically, in the different sizes or ranges you're going to buy the contactor. Might be 9 amps, 12 amps, 30 amps. And then your overload relay you're going to buy in a more or less matching physical size. And then there's 14 models of interchangeable heaters. So you might have a motor, again, it pulls 11.2 amps, and you're going to buy your heaters based on the application. And these are ambient compensated, and let me explain real quick what that means. There's a lot of times where your motor starter with your overload relay and contactor might be located in a building where it's heated and humidity controlled, whereas the actual motor might be in a pit someplace outside where it's cold and damp. So you're going to have a temperature difference.
Right.
So in those situations, you can't go entirely on the current being pulled by the motor. So what this allows you is to compensate for that difference in ambient temperatures with some adjustments on the overload thermal overload heater. This is bimetallic. Basically, over the years, there's been two basic type of overload heaters. One is the bimetallic, and basically it means two dissimilar metals. And as you heat them up, there's actually a little heater, so the motor current going through the heater actually heats up. And the bimetallics, almost like a thermostat, an old style thermostat, being two dissimilar metals, they expand and contract at different rates, so they actually physically move. And there's a trip mechanism in there, so if it heats up and it moves so far and it's calibrated, it's going to trip out a set of contacts and drop the motor out of the circuit. The other form of heater that's been around, and again it works on the principle of actual heater that the motor current is going through, is actually, it's an alloy solder. And so what you have is a spring-loaded pin with the solder on it, and as the heater heats up, it melts that solder, and it has a very specific melting point because of the alloy it's used, and that releases the spring mechanism and trips out the normally closed auxiliary contacts. Those have always been the two popular types. The only ones we currently carry are the bimetallic at this time.
Okay. All right. Next slide.
Okay. And again, just a quick wiring diagram.
Tom spent a lot of time on these wiring diagrams.
They were fun.
I'm sure everybody's going to start asking for them now.
I want to put them in their
He might
panels.
charge.
Next slide, we get into our CH series, and what's nice about I'm calling them CH, GH series. These are in a little bit larger range. They're IEC, they're in the B to J, so we can get up to 40 horse. We still offer the 120, only the 120 and the 240 volt coil, the most common that are out there. We offer these in a 45 to 60 millimeter width. That's going to be part of this series too. These are our own brand. These are manufactured for us as our brand. Again, I guess I should have said with the back with the Eaton Cutler hammer and this series, these are kind of our lower horsepower solution. If you get much above 40 horsepower motors, then you'd get into the Fuji series.
Can I make a real quick comment?
Yep.
One of the customer was asking a minute ago about IEC versus NEMA. A lot of times, a lot of people look at IEC being European standards or something, and NEMA being U.S. standards, and you start to think, well, I don't want to start putting European standards in my automation, in my American machine. But something just caught my eyes, even on the certifications on these, even though they are IEC, it's just the standards, but they still are UL approved, UL listed. They're CSA, CE, so they have all the same ratings.
All the agency approvals.
Right, approvals. Excuse me, that's the correct word there. Yeah, the agency approvals. So it's just the style, like you said.
Yeah, and again, it goes back to, I think at the time, IEC was getting pushed, like I said earlier, was people were looking for ways to save materials and money, and maybe it was the predecessor to going green at that time and everything. So,
all right, sorry to interrupt.
Oh, no problem. IP20 finger safe. Basically, all that means, even on the circuit breaker here, I can't get my finger down in here to touch a live terminal. So all
if I have small fingers, I might be able to.
But all the starters and the overloads have the IP20 finger protection. The the nice part about the GH series and everything, again, we can create a very inexpensive reversing starter by just buying the mechanical interlock. And if you want to do it properly, you also want to have the normally closed electrical contacts to form an electrical interlock between them. But that whole package there, reversing starter, and then we can jump into the MS series of motor starter protectors. Here again, we have something that's very similar to the Fuji with the rotary handle manual motor starter that we were talking about earlier. So if we flip back over the chain, what Shane's holding is the MS series, which is another manual motor starter. So it has the overload protection, and those are purchased in ranges. And if you can see on the front there's a little black dial where you can actually adjust the current, but you got an on and off button.
Mm-hmm.
We also sell auxiliary contacts. And again, we have the situation with the base plate that Shane's holding. We can put the manual motor protector on that base plate, add a contactor to it, and our overload protection, our overload relay is actually built into the manual starter. So with the contactor, we end up with the short circuit protection, the overload protection, and the contactor, so we end up with a combination motor starter.
Okay, cool.
Yeah, I think I threw another little schematic in here showing a reverse. Okay, jumping ahead, we want to get into circuit protection. So we talked about motor control. Now we're in the circuit protection side of it, and so we're going to cover our molded case circuit breakers.
Don't make me hold this very long.
And also supplementary protection. We'll hit on that real quick. Fuses and disconnect switches. So our first item is molded case circuit breakers. We're not going to get too heavily. Let me jump ahead here and everything. We're not going to get too heavily into the UL 489, but I think in a future webinar, I think we're going to open this up and start talking about branch circuit protection and some of the newer code that's out there for disconnecting means. Everything we've talked so far, you have one motor and one means of control, but there's situations where you might have multiple motors, and you want to hold your expense down, so you want to be able to have contactors to control the individual motors, and there's cases where you might want one contactor running two motors, and each motor having their own overload protection, etc. We'll get into that more. We do have a link in here we'll get you to that'll help you understand the UL 489. So talking about circuit breakers real quick, we offer those in 4 frame sizes all the way from 100 to 600 amps.
Cool.
Supplementary protection, both for, this kind of gets into branch circuit protection where you have some kind of main protector coming into your panel, and then you have additional, in this case we might have some small 3-phase motors, and we can actually power them off of some small supplementary breakers.
Or fuses. Whichever you prefer.
And recently we came out with the little, if I can grab one here, this is our little terminal block protector. That's actually a little circuit breaker.
Mm-hmm.
And we offer those in different sizes, and there's a holder, and it's in the Denector series, and we also have the little LED on this particular terminal block that gives you an indication when the breaker's tripped. Next is fuses. The fuses, our main supplier of fuses is Edison.
There's one large, huge one there.
Yeah, let me.
That's one heck of a fuse.
But we go all the way up to 600 amps. We sell the fuse holders in single, double, and 3 poles.
Like this?
All the various fuses, both in current limiting with the CC class, J class. I think what you have over there's a bunch of J class fuses. And what's nice, we also sell the small dimensional type fuses, glass type and ceramic, in all the various ranges and voltages and types. And then finally, the next slide, I think we're going to talk about our disconnect switches.
Let me see if I can grab this one here.
we have a smaller one up here?
Yeah. We have so much stuff laid out on the table.
But basically in disconnects, that's going to be your short circuit protection, and also for safety, like we said in the beginning, we're going to talk, safety too. If I have a control panel with a bunch of motor starters and everything in it, I want to be able to maintain or troubleshoot or work on the panel. So I want some kind of main disconnect that I can kill power to everything and be able to lock it out, tag it out. So we offer a full range of both non-fusible disconnects and fusible. We also offer, I don't really have any up here on the table. That's a handle to that, but we also offer some quick disconnects, and basically they're load type switches. So there are situations like on transformers or other high voltage stuff where I might want to be able to kill power to it, and I want some kind of switch that is substantial enough that can handle the current and kill power to it.
Okay, so move on.
Yes, sir.
All right, sorry.
Motor control relays. This would be kind of quick on this too.
These are sort of accessories to an application. We've talked about these when we covered our what's new this year. Tom, there's several different ones. I know you've got a couple listed up there. Yeah, you got over voltage, under voltage, the phase monitoring. So they're like good monitoring devices basically, but they can.
Basically, yeah, the one you're holding there is the main one. That one, you actually have pots on the front of it that'll allow you to monitor for phase loss, but over voltage, under voltage, set the limit. And you might have sensitive equipment or a motor out there that you don't want the voltage to get too high, too low, and you don't want to lose a phase to it. And,
right.
That's a lot. And in the line too, it's still in the control line. We also have the one of the ProSense relays that'll do alternating for like pumps, like a duplex pump circuit. And then we also, especially in pumping applications, you're going to have seals, and there's
a leak detector.
Leak detectors, and we sell a relay that'll monitor the leak detector and shut the pump down if you detect a leak in the gasket or material or whatever. And then our next slide. Had to put a wiring diagram in here. So
loves his wiring diagrams.
We're showing the phase monitoring relay, how it would wire up to the power going to the motor and everything.
Okay.
And next slide, AC soft starts. This is a relatively new product.
All right. I'm going to stop you before you get too far, though.
Sure.
So what we talked about earlier is we talked about contactors. If you just wanted to start a motor, you just want to go from 0 to full run, you're going to use a contactor and its appropriate parts. Right?
Exactly, and that's
all the control you have. It's on or off, nothing in between. Soft start is in between, sort of a middle of the line, right?
Right.
It's going to give you a curve you can actually adjust your time delay and your power coming into it, right, or coming out of it.
Delay the I'll call it voltage ramp up. There's thyristors in here that break up the AC voltage going out to the motor and basically give you a soft start. And let me explain real quick. Best application I can think of is like a large squirrel cage blower. That blower is going to have a motor sitting there with a pulley on it and a V-belt on a small pulley going to maybe a large pulley, and you're going to have a big squirrel cage there. Under normal circumstances, if I start that motor across the line, it's going to try to come up to speed, pretty quick.
Chatter, belt squeak, maybe snap
bearings,
the belt.
Yeah, it's going to start wearing and tearing everything. So what the soft start does for you is it softens the start. It actually lets it ramp up the speed slowly, but it also allows you to adjust those parameters and then also monitor. And the one nice thing with these units, there's 2 different sizes, several different amperage ratings, and there's also a fan option. So I can pick one of these for a motor, and then if I want to give it a little cushion because I'm in a panel, maybe in a hot ambient area or whatever, I can add a fan to here to kind of give me a little fudge factor in the rating on it. But
so not only ramping up, you can also adjust the ramp down.
Yeah, it'll allow you to bring that motor back down to a certain extent with the adjustments on the front of it.
Okay.
And also we should mention, once this is up to speed, there's a set of contacts in here that take the thyristors or the solid state part out. So once you're up to speed, you're across the line.
Okay. So that's middle of the line.
There's a bunch of applications, and of course, we had to show you On the next slide, a schematic of how this would wire. There's a fault contact that you can wire into your PLC or circuit and everything to monitor the usage on it. And then finally, we get into AC drives.
All right, so contactors are on off. Soft starts, ramp up, ramp down. But while they're running, they're basically across the line. And then AC drives are variable frequency drives, VFDs. There's several names or nomenclature used for them, but they are fully programmable.
Exactly.
Ramping up, ramping down, if you want to give it full power or not, regenerative braking, controlling it with other devices.
Yeah, and like we mentioned in the beginning, there is another webinar we did on AC drive setting out there with Mr. Boatwright that is pre-recorded that gets into some of the details on our AC drives.
Okay.
And of course, we had to have a schematic, and if you're interested in the AC drives, there's a link showing there to the DuraPulse. So we do have GS1, GS2, and the DuraPulse drive.
Yeah, anything from a small drive like this to, if you go to the website, you'll see there's a big one that we're bringing in on a crane in the video.
Yeah. Very huge one.
Yeah. All right. I know we're pushing for time. We've actually ran over a little bit, but I wasn't going to stop Tom because there's a lot of good information about this stuff. We're going to stop for just a second to take a couple of the questions. We already took a few of them, so if you have any questions for us, go ahead and ask real quick. If we don't answer your questions in their entirety or if we're not real clear, go ahead and chat us, and we can always email you directly or get in contact with you directly.
We'll get tech support to give them a call.
Yeah, if need to. Yeah, don't forget, our tech support's always free, and they're just always willing to help. What, 9 years now, I believe?
First
best tech service.
Yeah,
here's one last question, Tom. Customer is asking, is this true that an overload equals over temperature or time delay, and a starter? Trying to see if I understand how to read this question. Is saying, is this true that one, an overload equals over temperature or time delay, and then a starter is over current or instantaneous?
Different. It sounds like, and I think we would need more specifics, but like circuit breakers, real quick and everything, because I had experience on testing circuit breakers way back. There's different curves they're set up for, and if he's talking time delay and instantaneous trip, he's kind of getting into the whole curves. And the overload, all the breakers have curves. If you go to our website, you're going to find the current curve. So as you pull more current through the breaker and everything, over time, if you pull the current, if the current's coming up slow, I don't know how to explain this real quick. If the current's coming up slow over a period of time, it's going to allow you to pull more current versus if you get high current quickly.
Right.
So there's different curves that are calibrated or calculated into circuit breakers and overload relays that allow different situations to occur.
Okay. All right. And like I said,
I know that probably didn't answer the question.
If we don't, you can always chat us, email us, or like I said, call our tech support. Don't worry if you don't know the product. Ask tech support; they'll be happy to walk you through it. I mean, every day they get calls of, I don't know exactly how this is supposed to work, but I know I've got to use it. We've all been there. All right, we'll go ahead and stop with the Q&A, but if you have any more questions you want to chat us, please keep doing so, and we can go back and look at those. All right, poll time, real quick. I'm going to discuss this. The free gifts we have listed up there are the USB pen drives. I'm out of those, but we have something that actually is even better, and from what I understand, these actually cost more because pen drives have gotten so cheap. I almost get them out of bubblegum machine now for 50 cents. But these are actually stainless steel water bottles, and we're trying to say it's green bottles because you're not using any plastics. You're not throwing any plastics out, whether you recycle or not. But no plastics in our landfills. But I know my dad went to buy some of these the other week, and he was griping about they were almost $20 a bottle. But anyway, our poll, there's 4 questions. I'll send you an email after the talk show. It says thanks for coming in. I'll give you all the information where you can find more stuff. And there's a link to a poll. If you'll go out to that poll, answer those 4 questions, put your name and your email address in there so I know who you are. Tom's going to pull your name out of a hat, and we will have a winner that will receive one of these. So please, it'll take you longer to put your email in than it will be to answer the 4 questions, and it's just simple yes or no's. So that's our poll. And on to information resources with Tom. I'm going to let you hit those, and then we'll wrap up.
We tried to give you a little bit of what we covered today, and believe me, there's a lot more to this than what we could cover in 40 minutes. But if you need more information on the contactors and overloads, there's a link there. The molded case circuit breakers, we have a link to an overview explaining them, plus the fuses, phase monitoring. One thing we talked about a little bit, and I think we're going to reserve that for another webinar because it's a subject in itself, is branch circuit protection. So, if you're running into a situation where, you have multiple motors being controlled out of a panel and you're trying to figure out, how to set up your circuit protection and starters and all that, here's a start. And of course, you can go on the internet and do Google and do UL498, and you're going to come up with a lot of information. And of course, there's our tech support number too.
And we'll send all this information to you in the thank you email as well, so don't worry about jotting it down. All right, so we're at the end. If I can get the engineer start up the end of the show, we'll go ahead and wrap up. And I want to thank everybody for coming in. Thanks, Tom, for putting together this great presentation. I know it was a lot to pack in, and we're at 50 minutes.
Real quick, I want to also mention, you're going to mention about LearnMap.
Yes, I'm going to hit everything here.
Okay,
so
gotcha.
Thanks for attending today for this edition of Automation Talk. Please, visit our main website, Automation Direct. Feel free to browse the site and ask any questions you've got. We have online chat on our website now. You can email tech support if you have any questions. You can chat to them live while you're sitting there. Go to Automation Talk, check out the recorded seminars that we already did on the motors and the drives. Sign up for any of our other Automation Talk shows. We already started listing next year's talk shows, so we always have 4 of them up there. As you can see there, we have our learn.AutomationDirect.com website that is video tutorials that Tom and I do most of them, but we break down this stuff into 5, 6, 7-minute videos and teach you more. Also down below that is the AutomationProfessor.com. That's Doug Bell that does all of our training. He's an independent, but he does all of our training for Automation Direct. But he has a new website. Now, he does charge for this, but he has, probably over 100 videos out there already, and he just started the site up a month ago.
All the way from the beginning, mostly on PLCs, and
he breaks everything down to the nitty-gritty and shows you exactly. But take a look at his site. He's got some free videos you can watch. And like I said, come out and watch some more Automation Talk shows. Thanks, and have a great day.